Hi everyone, I'm Julia Hyder, Senior Editor with Modern Machine Shop, and I'm your moderator for today's webinar, which is sponsored by HiQA. How long does it take to compile all of your customers' quality requirements? Today's webinar will show you how to automatically generate a complete submission package in less than an hour. We'll learn how to efficiently create, manage, support, and monitor AS13100, IATF 16949, ISO 13485, ISO 9001, and other industry submission requirements with a customized library of templates and forms, secure collaboration and communication, traceability and accountability for the entire quality process, streamlined PPAP and other quality process requirements using 2D drawings or 3D models, compliance to all quality standards and regulations in aerospace, automotive, medical, energy, and other manufacturing industries, and an automated paperless database-driven solution that doesn't rely on Microsoft Excel. Don't get left behind. Get up to speed with the new industry standard for quality. Our presenter is Tim Hogan, Vice President of Business Development at HiQA. Tim has been in and around manufacturing for almost 30 years, having worked for Tier 1 and Tier 2 suppliers and one of the leading providers of quality control equipment. He has a unique perspective, having been on the shop floor, working with machinists and working in the quality lab, ranging from programming CMMs to working with customers on submission requirements. You can submit questions for Tim at any time during the presentation using the Q&A tab on the right of your screen, and we'll answer as many as we can at the end. And I also wanted to let everyone know that this webinar is being recorded and attendees will receive a link to that recording via email. So with that, let's get started.
All right. Well, thank you very much, Julia. And thank you everyone for joining us. So today we're going to be discussing the AS13100 standard that came out last year. However, we've been asked if this webinar only relates to aerospace. And while the new AS13100 standard does apply specifically to aerospace and specifically aero engine, the tools that HiQA provides that aid in streamlining complying with those new standards is applicable to all industries that have any kind of submission requirements. What you'll see today is how we can automatically generate control plans, PFMEAs, gauge R&Rs, control charts, FAIs, and other submission requirements. These are the same requirements in the automotive, defense, and medical industries as well. I personally came out of the automotive industry working for a Tier 1 die casting and machining supplier. Our customers were Ford, GM, Honda, and others. That's why I'm so excited about what HiQA can do for you. I've seen firsthand the time and effort it takes to compile these submission packages. But getting back to aerospace specifically for just a minute. So what is 13100? It's a quality standard that was developed by a joint committee of aero engine manufacturers as part of the AESQ strategy group. It's an SAE standard, just like the 9100 and 9145 standards, but it's meant to supplement or add to those existing standards. It also introduces some new terms into the quality requirements, such as PPAP, APQP, and MSA. The term PPAP stands for Production Part Approval Process and brings with it 18 elements of quality, sometimes referred to as the 18 elements of PPAP. Now, whether you're in the medical, aerospace, automotive, construction, defense, whatever, most customers have adopted some form of quality system to address some, if not all, of the 18 elements. There are 5 levels of submission packages, simply referred to by the level of submission: level 1, level 2, level 3, and so on. The most common PPAP submission package is a level 3 submission. That's usually the initial package that's submitted. A level 3 PPAP contains 16 of the 18 elements, with only the master sample and the checking aids not included. The AS13100 standard incorporates these PPAP requirements. Some of the more challenging requirements to be added to the 13100 standard are the process flow, the PFMEA, control plan, gauge R&Rs, and capability studies. So under certain circumstances, these can add a significant amount of time and resources required to submit parts for approval. In fact, some companies hire additional personnel just to handle the paperwork. So, why do these requirements potentially add so much time and effort? Because oftentimes these systems are very, very disjointed. Prints are ballooned in one software, it's measured in a different software. Data is compiled in another software, or worse yet, it's put on a PDF, and then you have to manually transpose that to an FAI. SPC is calculated in yet another software. Gauges are tracked manually or in a standalone software. And gauge R&Rs are calculated or compiled in yet another software. On top of all that, the process flow, the control plan, and the PFMEA are typically manually generated in Excel. So now you can see why quality engineers and quality managers often refer to this as death by spreadsheet. There are so many different forms and spreadsheets and documents and lists to maintain and track and coordinate. A lot of companies have full-time employees whose only job it is to compile submission documentation. And that's where HiQA with our PQP application helps to streamline and automate your quality documentation process. We do this by providing the tools to keep the digital thread intact and increase collaboration within your organization and even outside your organization. From the time you acquire the information from your customer, the collaborative digital life cycle begins. Now, it typically starts with data from your customer in a 2D or even a 3D model. So then you can start the planning phase where you automatically balloon the drawing, extract the information from it, including the GD&T, create inspection plans, assign measurement methods, sampling rates, and even assign special designators like key characteristics. Now, on the production side, you can manage all the gauges in your facility, collect all the inspection data, both from in-process checks and final inspection, and even provide real-time SPC data, including notifications for out-of-tolerance conditions. And if a dimension's out of spec, it can, if you want, create and track non-conformance reports digitally. Now, once the plan is made and the data is acquired, this information is used to automatically generate your full submission package. No more 20-tab Excel spreadsheets. It's all in the database. That's right. HiQA is a database-driven solution. So everything that's done is live and real-time in the database. We won't have time to get into this today, but where you could ultimately evolve to is collaborating with your suppliers. Imagine getting the submission information back from your suppliers digitally and having it sync right into your database as if you did the work yourself. Your suppliers will become an extension of your shop floor instead of having an entirely different system to handle the data separately from your own data. And they don't have to have a HiQA either. If they do, it's a click of a button. But if they don't, they simply upload their data to the supplier hub. But either way, it's a direct feed into your database. Secured, of course. Imagine analyzing data from two different suppliers with the granularity down to the balloon dimension number. And you can do this even before they ship parts. So supplier collaboration is the ultimate goal, and it can be achieved efficiently and digitally with HiQA. Okay, let's hop in the software and show you how we can streamline the entire quality process. Okay, so we're going to start in HiQA. And we are going to, there's three ways to start. We can start by wizard, by drawing, or by a 3D CAD model. We're going to start by a wizard, just a simple two-step wizard, to where the first step is we're going to select the print that we're going to use for ballooning for the initial phase. Now, when we click next, the second step of this is a very important step. And the reason it's an important step is because it's going to allow us to apply a lot of defaults to the system, mainly around what we call the part category. And that part category could be maybe specific customer requirements, or if you do a specific part type, like we do housings all of the time, and it always has these same defaults to all of the housings. Well, great. Let's combine those defaults together so that way they're automatically populated and we don't have to change them. Now, that'll make more sense. I'm going to come back to this idea of part category several times, but just want to let you know it's as simple as applying a part category and then applying it to this specific part record or print. Now, in this case, we're going to use Acme Tool, our fictitious customer here, and we'll just say complete. Now it opens up the drawing in HiQA. And now we simply come up to our auto balloon function right here, and we click on auto balloon. And it gives us some options here. We can select multiple pages up at the top. In this case, you can turn off balloon and reference. Let's go ahead and do that. We can see how that looks. We can automatically detect surface finish and other characteristics. We'll just hit OK and let it run through the process. And now what's happening is we've developed our own OCR, optical character recognition, to analyze the print, take the information from it, figure out what's a dimension, what's not, avoid certain areas. And you can see that was done in a little less than 20 seconds. Our print is fully ballooned. The basic dimensions were avoided. But most importantly, if I scroll this up, this is what we call our bill of characteristics. Now, this is a window into the database. The information from the print has already been extracted and populated in the database from the requirement, and then it also determined what type of dimension it is, nominals, tolerances. All of that information has already been populated into the database from that print in that first 20 seconds. Now, taking just a pause here, let's talk about the part categories again, because in those part categories, we have some defaults that we set up. For example, the sampling rate. For the sampling rate for numeric dimensions, meaning dimensions that have a number associated with them, we have our sampling rate for Acme Tool set up as 1/20, so we can automatically apply those. What you'll see later, as we get further into the demonstration, is that information will be used in a couple different areas. In one area, it'll be used to create our samples when we go to measure parts against there. Okay. The other thing it will do is automatically populate into our control plan. So as we're adding things here and changing them, our control plan will be updated as well. And you'll see that as we go. Just wanted to point that out now. Additionally, we looked here, or when you look here, we see that the type was automatically kind of figured out or analyzed during that initial ballooning process. We also have some defaults in the system for a gauge category to say, for this type of gauge, for example, for this linear check, automatically apply a caliper for the gauge category. Now, whether that's realistic or not, we don't know. But we can set up defaults, and it's that 80-20 rule, right? We've tried to set up the defaults to capture 80%, and then we always need to go fix or update that last 20% as needed for this specific part. So that can be done automatically as well. So let's scroll that back down. And we also have other features in this software that would love to show you. For example, we can extract information directly from the print itself, being we have this pretty neat and pretty accurate OCR. Let me switch this view over here so you can see what it's doing. We'll look right up over here. And all we're going to do is literally box select this and say, this is the part name. And then we'll see the part name update right here. Now, I didn't type anything in. I'm not typing anything at all. I'm just simply box selecting that and saying that's the part number. And now we can see the part number updated. Now, what it's doing is it's using the OCR to populate this. And this usually is better for accuracy as well, because you don't have to worry about mistyping information in from a human or an individual. Okay, so we can use that information. Notes, we can also balloon notes in the system. So we'll click right up over here in our balloon note tab. And then we can just select whatever the note is, right? And when it balloons the note, it uses the OCR to figure out what it says, and it populates it in our bill of characteristics down here in the bottom. You see it there as well. It automatically applies a balloon number as well. And you can have as many as you want. And you just keep box selecting them. And again, it figures out what's using the OCR, what it is. And you can click and drag these around. You can see it has automatic leader lines if you need to, move it away. Not a problem at all. Some neat comforts. Let's say if you just want to label that as number 1, you can simply label it as number 1. Not a problem. You could name it or number it however you want. It's very, very user-friendly in the system. Now, I'm going to come back to material later on in the demonstration. And being this webinar is focused more on the submission requirements, I'm going to briefly just highlight a couple of characteristics in the software without getting into it too much. For example, this 4x dimension you see right here, you can leave this as the full dimension 10, and you'll notice down here it says 10.1.2.3. We can break that out individually like this to where you can uniquely identify those 4, or you can leave it captured under one balloon number. Completely up to you. No right or wrong, just different way to do it. We also have a couple really neat functions. One of them is called whiteout. So let's say it missed a dimension, for example, like this. What we can do is use our whiteout function and hide everything that it did acquire during the process. And now we can easily see what it didn't. And now we can manually add that by just selecting it, box selecting it, just like we did with the title block information. And now that we have it figured out, as soon as we box selected it, what it was, and applied that, and also applied our gauge category because it's a linear. But now we're out of sequence, right? So being we're out of sequence, we simply fix anything that needs to be fixed, come up here, hit renumbering, puts everything right back in line exactly where it should be. Okay. So that's a couple neat little creature comforts. There's many more, but again, we're going to omit some of that to focus more on the submission side of it. So let's take this 2-inch dimension, for example. So in this dimension, we can see that we've already applied our gauge category of caliper because it's a linear dimension. And we can see down in the bill of characteristics, let me scroll this up a little bit so you can see it. In our bill of characteristics, it's noted as 1/20, right? So let's say, for example, that this is a critical characteristic, or flight safety or a CTQ, something along those lines. If we select the designator and hit save, a few different things happen. One of them is we have a designator column in the bill of characteristics that can identify, oh, this is a CTQ. But we also can set up rules in the system. For example, I have a rule in my system that you're looking at right now that if it's a CTQ, automatically update my sampling rule to be based on an AQL table instead of whatever the default was, that 1/20. Okay, so we can set up rules that says if this happens, then make that happen. Now, the neat thing about this is that this sampling rule, again, will be used to not only generate our samples, but it'll also automatically be transferred to our control plan for the sample frequency. Okay, so that's wanted to tie those pieces together. No, by the way, gauge category, that'll be the measurement technique on the control plan as well. All right. Also, I have just kind of a neat little creature comfort. I have a little square here instead of a circle. You can set up different defaults in the system as well. Okay, so talking about gauge category, I'm not going to spend a lot of time on this. Again, we're going to get to the submission side of it. But from the measurement gauges, we do have a full gauge management system right in the software. It's not extra, it's not different, because we correlate the information from the gauges to the data, which you'll see in a little bit. Okay, so it does what you kind of expect though, right? We can import a list from your existing gauge software or Excel or what have you. We have notification settings to where you can notify people for certain, out of calibration or coming up soon or what have you. And then you can add your cert details here, calibration frequencies, all of that. But we also track usage. So you'll have exposure in your system to know every single dimension that that gauge has ever checked, right down to the job number, the lot number, the serial number. If we scroll over, you know who checked it, time and date stamp, category, if it was tied to a machine or a nonconformance, all that information is transparent to you and available at the click of a button. So again, not digging too far into that, but at least want to let you know that it's available because we're going to be tying that back in just a minute or in a couple minutes. Okay. So getting back to our submission levels. Now, when you get this part in to actually make it, you're going to build this into operations, assuming that you're in some type of machining process. So we have a manufacturing operations tab right here that we clicked on here. And now we can add operations. Let's say, for example, we want to add a roughing operation. We can click, and I'm just holding down Control and selecting different dimensions. Now, these are the dimensions that are going to be affected in this specific operation, right? And we're just going to click Add Operation here with those 4 dimensions. And we can see an Op 10 over here. Let me change the color of the finish so you can see that a little bit easier. There we go. So now you can see we have an Op 10, but we can add information into that Op 10 as well. Maybe we want to call this our roughing op. Now, actually, this is one of the first times I've actually using the keyboard. Okay, everything else that we've done so far has been just from pointing and clicking. And we can even put additional information here. Maybe if there's a work cell or a specific machine even that we're using for this. But let me pause here and mention something because this is an important aspect. So we're breaking the dimensions down into different manufacturing steps. But we also have this pull down here for process. So what we're doing here is identifying a process associated with an operation. As the quality people with us today will know, most of our documentation is built around a process flow diagram, PFMEA. So when we tie those together, what you'll see later on is that the PFMEA, the process flow, those are automatically generated based on tying this process to this operation, okay? Just want to kind of point that out. So as we're going to identify the process here, now we have our roughing operation and a roughing process as well. I'm going to add a few more here, so pardon me just taking a couple minutes, but you can box select them like I'm doing. You can individually select them however you want. It's really kind of up to you. So we're just going to add those 4, and I'm going to go in and manually, let's call this a drilling operation. We'll tie this to a drilling process. Say okay. Let's say we mill this. And you can name them differently than what the process is. For example, if I just say like turn here, and then tie, and again, you can put as much information here as you want or not, totally up to you. We'll tie that to the turning process. So now we have our operations identified, the dimensions identified over here on the side, and then the process associated with those all identified. All right. So now let's go into our PQP records. So now we're going to start building our documentation right off the bat. So we do have to associate it to a job. And let me pause here and also mention that we do have an open API. Now, what that means is we can communicate to other softwares as well. Mainly with job information, that information will be entered into your system in your ERP. Well, we can communicate to your ERP, or you can take that information and have it fed down into HiQA so it can be automatically populated. You don't have to manually do this each time, although you can, totally up to you. But just want to let you know, we do provide another level of automation there as well. But you can simply create a job right here, and I'll just create one quick. HQA1, we'll just make it active. And really what we're concerned with is the quantity. We'll just stick a quantity of 75 parts in there. Also note right here, we do have it set to auto create default PQP documents, okay? So what happens is when I hit save, it's going to automatically set up a submission package index. Index is the list of documentation submission requirements here. And we also had it set up for automatically populating a process flow. Now, let me show you where this information came from. So I keep talking about these part settings. So if we look in the settings tab and we look in our part categories. So in our part categories, where we initially selected that, if we look over here on the side, we selected Acme tool at the beginning. If I select Acme tool here, these are the different settings you can have for defaults for this specific part category. For example, we had a specific you can have specific decimal tables or range tables set up for those to be applied to the print as soon as you balloon it. I don't know if you noticed, but the dimension color was purple when it was ballooned. That's because we had purple set up here. So even just kind of, let's call it silly stuff like that. But when we get into our AQL, I pointed out to you that our sampling rate was set at 1 per 20. That's because that's what was listed right here. And our pass-fail dimensions were set at 1 per lot because that's what was listed here. Now in our PQP, our index was set up as a level 4 for Acme tool. You could have as many different indexes as you want and have the submission information inside of those indexes to be, again, completely configurable and even custom if you'd like. So in this case, we had a level 4 PPAP for Acme set up. We have a basic workflow, and I'll talk about the workflows more in just a few minutes. But we also had a default PQP, and we can see the process flow right here. We have a lot of other documents as well that can be automatically generated from this. However, I wanted to automatically, or excuse me, manually do that so you could see what it looks like. But you can automatically set multiple document instances to auto-populate, and you can see auto-create is checked as well. So that's where that information came from. So when we selected the job HQA1 and it created this index, our process flow was automatically created. If we click into it, here's where things start to correlate together. In our manufacturing operations, we added 4 operations: roughing, drilling, milling, turning. Those were automatically put into the process flow, okay? So now we can add additional processes that are outside of manufacturing. You can see right here we have non-manufacturing and manufacturing. Let's say we need to, order the material and receive the material. Need to ship the parts out, and let's say we need to inspect the part. Let's say that's going to be our process. So we'll select those. And now here's our process flow that was automatically updated, order, receive, and we just need to drag these into the proper order that you want them in. Let's say we're going to inspect it right before we ship them. Automatically renumbered for us, right? That automatically done, so we don't have to remember to do it. So our process flow has already been updated. And when we go back to our index, we'll go into the PFMEA in just a minute. I actually like to pause here and start tying together the data. So one of the elements is building the package, right? The planning portion of it. Secondly, we have to acquire that data and get it back into the system. So we can do that a couple different ways. If you have a CMM or other type of automated system, we have a product called AMDI. It stands for Automatic Machine Data Import. So whether it's a Keyence machine, if you're running CAM2, if you're running MeasureMind or PCDemus or Modus or Polyworks or whatever, Calypso, mCosmos, we don't really care, to be honest with you, because we can automatically bring that information into high QA automatically, and it happens in the background. Let me give you an example of what that kind of looks like. So what we would do is set up a folder like this. This is just an import folder. You can see that here, that we're listening to. So HiQA is listening to this folder location. So in theory, what would happen is your CMM would execute a part program. It would complete, and it would save the report out into this folder location. So essentially it would look something like this, and it would just populate into there, and that's it. Now we would be listening to this folder location, and we're going to automatically bring in any file that hits this folder location. Okay. So I'm going to mimic that, or what I'm going to mimic is like doing like a 30-piece capability study. So we just copied and pasted 30 samples into here, representing us running 30 pieces on a CMM and having it automatically saved to this folder. Okay, we're going to come back to this later. But let's talk about information on the shop floor itself. So we have a shop floor data acquisition tool called Explorer, and each individual employee at your facility would have their own login, and we can scan badges as well. So this is where you would enter in information from like a manual tool or a manual check, like a caliper, micrometer, things, something along those lines. If your job in your system, in your plant, manufacturing facility, has a traveler or a router that goes with it, if that traveler or router has a barcode or QR code on it, the next step I'm about to do, you actually wouldn't have to, because you could scan that barcode and then it would pop up with the correct job for them to fill out information against. Okay. So it's very, very helpful in streamlining that. Additionally, you can use this as a check-in and check-out system for gauges. Let's see the calipers, for example. Here's our list of calipers that's tied to the original. And we can also change this list to being it's tied to that core data to make sure we don't use expired gauges. But let's get some data in here. We'll go into our gallery search, and now it's simply up to the operator to select the job that they're working on so that they can enter information against. And they could scroll through here, find their correct job. They could go by job number. There's our HQA1. We can click into that. And now here's the lots, and we have a nice dashboard, lets us know how complete it is, if there's any failed dimensions. Now, really like to point this out because this is one of the elements to where you can start to see some streamlining that happens. So back in our main system, when we were in our drawing and we were setting up our bill of characteristics, we had set up that 1/20, right? We also set up CTQ, excuse me, that was AQL based, right? So what happened is that when we created that job, it automatically created these sample numbers based on the frequency that was set in the bill of characteristics. And you can see that we have the quantity of dimensions that need to be measured. So this is based on the AQL table, right? Based on a 75-piece job. We need to measure this one dimension because this one was set up as our CTQ, right? So that's how we can automatically set up those samples and help streamline that whole process so you're not doing it manually. Just wanted to kind of point that out to you, but let's say we just need to enter information against it. And let's look at our roughing operation, for example. And now we have some information on our roughing operation, right? We can have our nominals here. We see that we have gauge category listed as caliper, right? Well, how that helps going forward is that when we select the exact tool that we're going to use, meaning gauge, for this, it sets up the category and just gives us the list of calipers. So it helps to streamline that process later on. And also we can stop any data from being put in from an expired gauge. So you wouldn't have to worry about that accidentally happening as well. But now you would simply select the exact gauge that they're using. And if they need help in understanding how to use that gauge. We do have instructions right down here to where you can have gauge instructions or work instructions correlated with that specific dimension, right in the system and right in the database. So as you're updating those digitally in the system, those will automatically be transferred here as well. But now we can simply enter the information that we need here. Let's go back to our measure screen. And we can say, oh, this is 0.52 and hit accept. And now this is a live feed into the database, right? So it turns green, automatically scrolls to the next one. If this was a pass or fail, it would look like this. And they can simply say, oh, this passed, hit accept, same idea, right? Bumps to the next one, toggles to the next one, excuse me. But let's say it's bad. Let's say they accidentally, or they enter a bad number in. Let's say they enter 44 in. If they hit accept, now you can see, oh, wait a minute, are you sure? There's a double check in the system so you don't end up with a weird number out in left field and you're like, wait a minute, what did this person really mean? So now it gives them the option to measure again. Nothing was saved in the database. That just allows them to enter it again. But if it really is bad, they can say keep failed, and it automatically pops up with a non-conformance record for them to fill out right at the point of failure. They would say add new, and it has all this information already because it's in the database. And once I hit OK, these would be your defect codes, whatever makes sense for you. And now that non-conformance is logged in the system. It's tied to the individual that's logged in, right? I'm logged in up here. It's tied to the gauge that was used. It's tied to the job, the lot, the serial number, the dimension. All of that information is tied together and available in the system itself. Okay, and it also turns red here because it's real time. Okay, so that's the shop floor data acquisition side. Let's get back to our PQP and building that submission package. So we have our process flow already that you saw. Let's go into our PFMEA. So when we generate our PFMEA, we could do this automatically. Remember, we had to, in the instance, I'm doing it manually because I wanted to show you how to do this. We just have a nice little write-up on the PFMEA. Now, do want to point this out to you. And this is by default. You'll never have to change this. But if you look right here, this is the serial number of this process flow diagram. And if you'll notice, it's the same as here. What this means is that these two documents are tied together with the same information. So they can't be different. We used to get dinged every once in a while on an audit to where like your control plan and your PFMEA, you had different information on those, or maybe one was updated, one wasn't. That actually can't happen here because the information is tied together from the core information in the database. Okay, let's talk about workflows for a second. So every document that you have in the system or in the submission package will have its own workflow. So notice that there's 4 workflows right here. You can have as many workflows as you want. One of the configurability benefits from high QA compared to other systems is that usually other systems will say, yes, we have a workflow for that, or we have a workflow for this. And with high QA, it's what do you want the workflow to be? You can have as many workflows as you want here. There's 4 here. You could have 104. Doesn't matter. And they can be as many steps as you want in any type of configuration you want. Okay. So this one's set up to where the QC inspector drafts it, the procurement manager signs it, and life is good. So with that, notice also that these are titles, because when we get to the next step, now we can apply individual people to this and say, oh, this Tim or Joe can enter this information, and Scott's the manager who's going to approve this. No problem. We'll hit next. Now, this is really cool. It doesn't look really cool, but it actually is because the PFMEA template is here. Okay, so for all of these submission requirements here, you can have custom forms and templates set up in the system to where you can select the correct form for that customer. Let's say one of your customers, let's say Acme Tool, had a specific FAI form that they wanted you to use. Okay, great. We could set up that Acme Tool FAI sheet in here, and then you would simply select it in the list here when you're going to create that FAI. Okay, so it's all completely configurable. Excuse me. We'll hit complete. And now our PFMEA has been generated for us. It took the operation and the process from the process flow, and then it went up to what we call a process library and pulled in all of the failure modes that were in that library. All right, so it was generated for us. Very similar to probably how a lot of people do it. Usually you start with a template and then tweak it for the individual part. Same idea here. So we started with that information from the library, and now we can tweak it accordingly here. Maybe this isn't a 1, maybe it's a 10. No problem, that's automatically calculated for us. And then we can also add any specific information that needs to happen for this specific part here. Additionally, something that's pretty neat is you can have specific suggestions here. So that way your data in your PFMEA is consistent from one to the next, and you don't have like 37 ways to say broken drill, right? So it's consistent that way. We can go back to our index. And by the way, I mentioned that that comes from a library. Let me kind of give you another kind of peek behind the curtain here. And if I say manufacturing, I'm going to look in my process library right here. So here are all the processes that I have in my system on my computer here. And if I look in my drilling operation, for example, when it pulled in the process flow, it pulled in a fabrication step because that's what was listed here. It's going to pull in whatever is here. And if we have our template FEMA, here's the information. Here are the failure modes that were brought in for this drilling operation, or I should say for this drilling process. So when this process is identified to the operation that we selected, it's automatically going to bring in these failure modes into the PFMEA. And you can see right here, here's our 132 that we had before that we changed. Now, if we changed it here, we're changing the template. So now it'll be updated for any future times that this is pulled in. So this is also a good way if you're doing like a continuous improvement project for it to be logged and tracked in the system as well. But let's get back to our submission package, and we'll go into our control plan and say create PQP document. And it's much the same. I'm going to go through it much faster here, tied to the same process flow, same workflow. And by the way, you can add the people later, so you don't have to do it in this step. Whatever template that you want for the control plan. Oops. And then say complete. And now our control plan was automatically generated from the information that's already there, right? The process and the name that came from the process flow. All of our dimensions were identified when we ballooned it. The type was identified. Here's the dimensions that it has. The evaluation technique, that was the gauge category that was automatically populated, but can be changed. And here's our frequency, 1 per 20, AQL based because that one was our CTQ. So all that information that we did at the beginning is automatically generated here. And if you'll notice, like if I click on this diameter, I can't change this here. So this can't be changed because it's linked to other data. So you can't change things here. You'd have to change the core data, which would then, update and populate the rest of your documentation. So the control plan is effectively created for you, right? Okay, let's go back to our index. And let's go back. I forgot to do this. Let's talk about the material for a second. So when we click on our materials tab right here, it's going to change this over to materials and processes. So if I select the material here, we can see that it selected it here. And there's our pencil again. We can add information. I'm just going to type in some, whatever data here. Maybe you have a spec number that you're using. You can even tie it to a specific supplier. A lot of customers will use this as like a material cert, and they'll upload the material cert. I have a sample one here. So they'll keep track of their material certs right here in the system. Right here, we have a tab for materials and processes. That information has been entered into the database here. But also for our PQP records, If we click on this button right here called Sync Materials and Drawings, what it's going to do is go back to the drawing, grab the ballooned print, populate that into our submission package and design record. It's going to create an additional spot for the materials and processes here, and it's going to automatically generate our material into it. And if we click on it, we can see here's the information that we just entered. Here's our attachment. There's our material cert that we just uploaded. So we have all of that information automatically done for us for our submission package. Okay. But let's create our FAI as well. So we can go into our FAI, say create PQP document, much like we did before. Now, this is a good instance to where we have multiple options here to be able to select it. We'll just click on our AS9102 right there. And now we need to select the sample that we need. So here are our 30 samples that we automatically pulled in from our CMM that we populated into our folder here. So our CMM ran, populated into the folder. We read that in and automatically it's automatically in the database. So now those samples show up, all 30, in our options in order to select it. Let's say we're going to use sample number 1 for our FAI. What operation? We're going to use our finished part. And you can obviously tell you have options for, partial FAIs in that. Same idea, workflow. And again, you can change the workflow. When we set up that default, that's, again, just a default. You can always change it to whatever you want it to be. And where we want it in the selection, we'll hit complete. Now what's happening is it's taking the data from the FAI, from the CMM, taking the AS9102 template that we have in the system, and then merging those together and creating our FAI. Anything you see in yellow can be typed. So I'll just put in typed here. Now that can be typed in, but anything that's not yellow is linked to other information and it's automatically generated. And again, just to recap, this is completely configurable. You want your logo up here, your customers, different color, whatever you want. You can have that on here as well. So the AS9102 Form 2 has all your material information, and here's the same material information that we populated. And here's your Form 3, has all of your data that was automatically brought in from your CMM and generated on your control plan, from your control plan, but also put on your FAI. Notice the designated tooling. This is linked to the gauge category, which is also the measurement technique on the control plan. So that's consistent. We could also have it being that we're tied to the same gauge database. We could also have that populated with the gauge serial number, so you know the exact serial number used as well. And if it is out of spec and there was a nonconformance created, it would automatically be populated in our nonconformance column as well. So all that information is there. So if we go back to our drawings, let's being we want to track SPC, let's track this a little different way. Let's say we want to track SPC on here because we now have all 30 pieces in here, right? Here's our 30 pieces of sample. We see our 30 piece right there. So they're all in the system. So, but we didn't tell it we wanted to track SPC on anything. So if we just select a dimension, same spot we were before, right at the beginning, right? But down at the bottom here, we have AQL and SPC. So now we can say we want to monitor SPC, and we're going to hit save. I'm just going to do that to a few different dimensions. Let me grab this diameter here, hit save. I'll grab this linear dimension here. Okay, that's good. So now that we told it, hey, we want to track SPC on there, remember the data is already in there. So it doesn't matter how old the data is, it's in the database. Even if we click on our SPC tab up here, here's our SPC data already in the database. If I want to know more information about this diameter, here's my run chart. There's X bar and R charts, histograms, your capability information's there. So that's all part of the database and available real time. Right? But when we want to put it into our submission package, we'll go into our PQP records and then click on our SPC report and say create PQP document, just like we did last time. And again, here's different options. You can have different forms in here. We can say, let's say we want to do our control chart. In what operation? Well, we're going to use our finished part because it's a CMM data. It's automatically going to say, do you want to use the boxes that you checked already for SPC? So sure, we'll use those. So we have our dimensions here. Do need to change the date because it's going to use a date range and it's going to default just to right now. So we'll change the date. Again, same process, workflow, person, we hit complete. Now our SPC data will be automatically updated from, our SPC charts will be generated from the data that's in the database from the CMM information that was automatically put in, right? So here's our SPC control charts. These are configurable, whatever you want them to be and whatever information you want them to show. These are just defaults in the system, okay? And these come with it. Also note, it did say signature right down here. We do support digital signatures. If it does require signature, it would show up on the form and it would also show up in the system right here with a time, date stamp, IP address, who signed it, who was logged in, all that information, because everything you do in here is log tracked and traced. And we do have history of those changes. Okay, so we're getting a little short on time. So let me run through this very quickly. Even our gauge R&R. Let's say we want to create this. We'll say next, and it says, okay, what feature name? We'll just grab one here, and what gauge. So you can have multiple ones of these. You can have, well, whatever you need them to be, quite honestly. One for each one. Same idea. It has to go through a workflow, people identified, and then where it is in the process, and we'll say complete. Now let's see, I have some gauge R&R data here. Let's say hypothetically that you acquired the data and you just had it on a worksheet in Excel. So that's what we're kind of duplicating here. We're going to grab this information in Excel. Now the gauge R&R is very similar to the other forms as well. Anything in yellow can be populated, and then anything not is automatically generated for you. So this is designed to where I can grab information like from Excel, for example, and I'm just going to hit copy, and I'm going to paste it right in here. And then it's going to automatically start calculating and start updating my information here based on the information that has been copied in here. So I'm just going to control copy, control paste. Grab this last set of data here, copy and paste. And now my 3x3x10 is automatically done for us and it's in the system. And this, I keep mentioning about configurability of the forms, and that's very, very true. So the configurability of this form, you can have, it's not just a pull, you can have pull down lists or radio buttons or anything else. You can also have like a date box, pull up, when was this done? So this was automatically configured that way, so it's easier for a person to set it up in the system. Now, if you'll notice as well, we have a progress over here on the side. So with it being in progress, the progress is associated with the workflow. For example, if we go into, well, let's go back into the gauge R&R. So in this workflow, gauge R&R is taking a minute to come up here again. There we go. So when it's part of this workflow, it's in this step. So that's why it showed the percentage that it did. When the QC inspector is done, they simply come up here to submit. And what that's going to do is, it's going to lock the form for one thing. You'll notice right here, we're in the view stage here. There's no more yellow, right? So it can't be altered, it can't be adjusted because we're into the workflow to where we approve or not approve it. So it's going to lock it and submit it to the next level for approval. given that if we look in the workflow, for example, we can see, oh, now it is set up for the next step and for the next signature. In this case, it's a signature, right? So that's where it steps through the process. We also have notifications to where if you log into the system and you have a requirement that you need to perform, it shows you this right in the system. And it even gives you a link to the form that needs your attention as well. Okay, we also, and we're going to kind of roll up here in just a quick second for any questions, but also note that we do have start dates and due dates here. You can use this as kind of a quasi project management tool as well. It's not a full project management package, but you can use it for project management for your submission packages as well, and track it that way. Okay. And then when you're done, you have all of your requirements complete. Once that's done, you simply come up here to build final package. And in this case, it says, wait a minute, you're not ready yet. You don't have all of these at 100. You still want to create a package. So once you have those all complete, you'd be able to build that final package and submit it to your customer in one file, because it's going to compile everything and put it in one file for you to be able to send to your customer. So that's how we can completely compile an entire submission package, including the AS13100 requirements, in less than an hour if you have all your data already. So love to open it up for questions if anybody has any.
All right, thank you, Tim. We're starting to get some questions, but there's still time to submit one. You can do that using the Q&A tab at the right of your screen, and we'll do our best to get to it. But if we don't get to it today, someone can follow up with you via email. All right, so our first question: can High QA be integrated with other systems such as ERP or quoting software?
Yes, absolutely. So we have an open API. So what that essentially means, kind of in layman's terms, is it's a roadmap to your database system. So in the database, it'll have different fields to where it'll route to. And then if your ERP system, or any other system for that matter, PLM system, has an open API as well, there just needs to be a little middleware piece written between the two to push and pull information based on certain, events happening. If a job is entered in an ERP, then take that job information and push it down to High QA. So yes, we certainly can integrate with other ERP systems or any system, as long as it has an open API and that middleware piece is done.
I guess this is sort of a related question. Can this interface with GE's ECAB system?
I'm not familiar with that system, so unfortunately, I don't know how to answer that question.
If whoever asked that wants to provide some more details, maybe we can get a better answer. But we'll move on for now. Are gauge categories already loaded into the software, or do I need to set up the categories?
A little bit of both. So you'll have some defaults in the system, and it's again based on that kind of 80-20 rule. We give you a significant amount of defaults in the system, but you can set up any category you want as well. It's completely configurable.
Okay. How can you set grid location on the print, example S1, A5, etc.?
Oh, that's super simple. So in our drawings, that's one thing I did not do because we have a little drawing zone grid right here. And then you would set your letters and numbers right here. And then you can literally move this around to wherever the grid pattern is. And then it automatically updates the drawing zone down here as soon as you let go.
Okay. Can this replace Gauge R&R software like Minitab?
That's up to you. So will it perform Gauge R&Rs? Absolutely. Will it do SPC? Absolutely. The level of SPC and what you need is completely your decision in order to replace it or not.
All right. Can High QA send automatic customer reports?
We can configure reports in the system very similar to how we came into the PQP side and went into the AS9102 report. We don't have it here, but you can set up your customers form and format in the system so that the information that automatically came in from the CMM, or even the information that comes from the shop floor data acquisition tool, that can be auto-populated onto your customer-specific form.
All right, it looks like it's noon, so we're going to have to wrap up today's presentation. I want to thank Tim and HiQA for making this webinar possible, and thank you to everyone for listening in. Again, you should receive an email with a link to the recording soon. Thank you for your time, and enjoy the rest of your day.
Thank you.